Scott Pearson here again. Today we're going to be on our extended school year secondary math resources page. If you scroll all the way down, today our topic is going to be relationships and functions or linear representation. We're kind of going out of order a little bit, but later we'll be doing the fraction representation. What you'll need today, make sure you go into the relationships and functions page. Once you get there, you're going to have two documents. The first document is going to look like this, where it's going to say relationship and functions. You're going to have a bunch of different information there, and it would be really good to have that on the side as you're working on everything. Here are the two actually that you're going to be looking at. The first one is a teacher workbook. So here's your teacher workbook. And if you could solve all of those problems even now before we get started, that's usually what I do in a professional development if I'm with all the teachers, is solve all of these problems very quickly. And we'll talk about, and what I also want you to do is tell what grade you think that question comes from. All of these questions are coming from our item samplers, and trying to familiarize teachers with the item samplers for the MCAs. The second document that you're going to want to have is this elementary concepts, and it goes from 2nd grade all the way to 8th grade. These are outlining our Minnesota standards in the linear progression, and it also has in 2nd grade what are the topics that you could possibly work on for linear. And as you look right here, identify, create, and describe simple number patterns. So that's exactly what's being asked of the kids. Then if you keep scrolling all the way down, it gives you every grade and some examples of what you could be doing. We'll be referencing this back and forth, but I'm not going to show it again. So here's our first question. Okay, Target was selling Disney Frozen Playground balls. If we buy 2 balls for $5, sorry about the typo up there, 2 balls for $5, how much would I pay for 7? If you want to pause it for a couple seconds and do the rest of the problems on that page also, that would be great. Now that you solved that problem, one of the ways that you might possibly have finished it, you came up with a unit rate. What you found is the price of 1 ball, which is $2.50, and you multiplied that by 7, and you came up with $17.50. And you could have had multiple different ways of practicing that and going back and forth. What we're going to do today is we're going to outline all of the Minnesota standards. We're going to talk a little bit about each piece. First, here are the 2 Minnesota standards from 2nd grade and 3rd grade. Identify, create, and describe simple number patterns. And then number 3, create and describe, apply single operation input-output rules using addition, subtraction, and multiplication. What does all of that mean? Okay, so I'm gonna kind of skip grade level 2 for a couple seconds and go down here. Look at the pattern. How do we extend the pattern? 1 with 6, 2 with 12, 3 and 18, 4 and 24. What is the rule? What is the pattern that's happening? I'm multiplying every number of my input by 6. And my rule is multiplying by 6. And what's the pattern? Over on this side, my numbers are going up by 1. Over on this side, my numbers are going up by 6 every time. And that is one of the ways of extending the pattern, one of the expectations we have of kids as we're looking at this standard. So going back to our original problem, one of the strategies that I like to talk to teachers about is this number line. So using a number line, how can you extend the pattern? Well, I know 2 balls was $5. What would I pay for 7? Can I extend that pattern? Well, if I know what 2 balls cost $5, 4 balls cost $10, 6 balls would be $15, and 8 balls would be $20. Can I figure out the rest of them? Can the kids go in and keep solving? And this is a number line model to kind of get kids thinking about how can I do that. And it's one of those things that we really want to be doing with kids as we're teaching and extending the pattern. Can we extend that pattern now? So here is that 2, 4, 6, 8. Can we ask the kids, okay, well, if 2 balls cost $5, how much would 1 ball cost? Would they have enough to figure that out? Most of the kids would be able to say, hey, you know what, 1 ball would be $2.50. Well, could we continue this pattern then? How much would we do for 1, for 3, for 5, for 6, or for 7? And could they come up with that answer? Most of the times the kids can come up with a very simplistic number or an answer with it, and they can extend those patterns. And those are the things that we want to be doing with kids, knowing that there's an order on this side and there's an order on for your x values and for your y values. So that's extending your number extending patterns. Okay, our next one is a table strategy. And kind of talking about the same thing. Here's our table strategy. A t-table is what we call it a lot of times. And now we have input output. So if one ball is $2.50, two balls were $5, three $7.50, four $10, and we're just extending the pattern. Can the kids put all of this in that pattern? And an interesting habit, or one of the things I like to also connect to kids in here, is input is the same as your X and your domain. And kids really get confused in our district with that, and I think it's actually a pretty common thing all the way across. Output is your Y and your range. So those are just some of the things that you want to be looking at as you're working through some of the problems. Now we're going to be going into unit rate and scale factor. Now we're starting to get into our 5th, 6th, and 7th grade standards with unit rate and scale factor. And there's this thing called a measuring space. And in the measuring space, what I do is I find my first measurement and my second measurement, and in this case it was balls. 2 balls were $2, or I had 2 balls and then 7 balls, and I had $5. And what I want to find out is what is the price of the 7 balls. So if I go 2 times what is 5, or take 5 divided by 2, and what is my answer? So here we go. Unit rate is a constant factor across or between two measuring spaces. So here is my work that I'm kind of showing up here. So 2 times 250 is $5. If I take that down here for my unit rate, 7 times 250, and that's probably what you did to solve that problem. Or I could go backwards. 5 divided by 2 is 250, and then if I do it to that one, I want to do it to the bottom. So unit rate, remember, is the constant factor across or between two measuring spaces. So as I'm going from the ball to the price, I want to figure out what the price of one is, and then I can multiply that times any part and and get my answer. The next one that we're going to look at, is scale factor. And scale factor is the multiplicative relationship within a measuring space. So we're looking at balls. Since we have 2 and the 7, 2 balls equal $5, 7 balls would equal how much? We want to look at what is the relationship of these numbers, the multiplicative relationship of these numbers. So if I take 2 times what equals 7, or 7 divided by 2, and I can come up with an answer, and that's 350, which is right here, 3.50. I can do the same thing over here. 5 times 350 would give me my 1750, and that's that multiplicative relationship, and that's your scale factor. And if you think about back to like those maps and graphs, and a lot of those triangle problems when you're in middle school and high school, in that geometry class, those are some of the things that you're going to be looking at and trying to solve with those problems. The next part with all of this is a graphing strategy. So if I took all of my t-chart tables and I put them in a graph, what does a graph form? Well, it forms a line because it's all linear math. So now we're moving to linear, and I had enough 2 balls for 5, 4 balls for 10, 6 balls for 15, and you continue on with my graph. It makes a nice straight line, and then it's going to start getting to your direct variation. We'll talk about that in just a little bit too. But then everything on this line could be an answer to that problem. So one ball would be $2.50, and I keep going all the way up. So those are just some things to think about as you're going through. The next piece, some of those problems that you solve. 2 balls cost $5. How much will 7 balls cost? Use drawing or words or numbers to show how you got your answer is the first one. And we started looking at that data. Next question. What we want to do is we want to extend that pattern. So what is the price of 1? Look at your input. We have 2, 4, we're skipping 6, and we go right to 8. Can kids extend that pattern? So how much would they expect to pay for 1? How much would they expect to pay for 0? How much would they expect to pay for 4, 5, 6, 7? You kind of get the picture. And if we can extend that, your input-output tables, kids can solve a lot of problems. Next problem is another problem kind of very similar to that. You have 6 and 8 and 10 as your input, and you have your output numbers over there. What is the pattern? What's happening? What we're going to do is look at how do you come up with an equation in a couple seconds, but extend that pattern. What we want to look at is the monthly cost. So at 0, how much is he paying? Is the question that we want to have kids be able to extend. That's a 5th grade problem. Here's a 6th grade problem as you're kind of looking at direct variation and the equation. Write the equation of the line and you can solve those type of problems. And then the last one is just creating that table and creating a rule, and we'll go over that in just a couple. So here's another problem that I got from the Region 11 Math Academy that was kind of a cool problem to have. So 6 apples cost $1.50. How much do 5 apples cost? How many apples does $5 buy? And it's really looking at all of these different components, your table, your unit rate, trying to find out what the price of one is, using that number line, and really driving kids back to that number line. Can they solve it and show their thinking and their work? And then also graph A and graph B, where the cost is here and the apple is there, and then we can start talking about some of those other things. To our domain and range of the balls, we looked at one, with an input of 1, our output was $2.50, to $5, and so on. One of the things that we want to start looking at is how do we create an equation based on this problem. One of the most simple ways of doing it, I always like going back to the y equals mx plus b, or the y equals the rule with something happening with x, and have kids look at what is the pattern, what is happening, and try the numbers and plug them in, see if it works. So this first one, 250. With 1, what am I doing to get 250? I could be adding, I could be multiplying. With 2, what am I doing to get to $5? Well, in the problem earlier, we knew it was multiplying by 250, so we're going to do that. So y would equal 250 times x. And in this equation, it's going to work on each one of those problems. But just have the kids identify what is the pattern that's happening, and you can go in. One of the more simplistic ways of thinking this is your m is your rate, that is what it goes by, and b is where it crosses the y-axis. So what it goes by and where it crosses the y-axis, and that's going to help you with that y equals mx plus b, and that's going to help kids a long way to start solving these problems. Here's a direct variation question that I pulled from the Smart Exchange. I don't know, I can't remember whose it was, but it's kind of a cool program that they had for a smartboard application. But as I was looking at it, what I wanted to look at, okay, from a graph, can the kids create a table? And the kids have to be able to go back and forth in 7th and 8th grade in our standards from a table to a graph, and actually it's introduced in 5th grade. So could they create a table? Here's our table. Look at the table. Does it have all of the numbers in it? Does it include 0? Does it include -1, -2, 1? I would tell the kids, make sure you put everything you know. What are the missing terms? And they can help them get the whole thing started. With the equation, y equals 3 over 2x, and that has to do with your slope, and then some type of application. What is it? Maybe it's a cost of how many hours you're working or something similar to that, and have the kids do something with some type of application.